Okay, so we're picking up on question number 4. This is part 2 of the interim assessment. So if we look at question number 4, they tell us that line V is a transversal, and originally they gave us all of these lines here, and the question is asking us, which statement is true? Which set of lines basically is parallel? Here we have W is parallel to Y, X is parallel to Z, X is parallel to X, Y is parallel to Z. They're asking us which of these lines are parallel, right? Well, if you look here, they did give us some information in this question here. They told us that for line Y, they told us this was 70. Excuse me, for line W, they told us this was 70. For line X, they told me this was 80. For line Y, they told me this was 110. And for line Z, they told me this is 100. So all I did was just complete linear pairs. If this is 70, I know that this is 110 degrees because these are a linear pair. And if this is 70, I also know that this is also 110 because these are a linear pair. And then figuring out that these are vertical angles is the next logical step. Or you could say that these are also linear pair. So I was able to fill in the rest of the angles here. For line X, okay, this is 80 degrees. I know that these are a linear pair that add up to 180, so this is 100, and the rest is easy to figure out as well. Line Y, they told me this is 110, so I know that this is going to be 70, this is going to be 70, and the rest is easy to figure out. And for line Z, they gave me that this is 100, so I know that these are a linear pair, add up to 180, also a linear pair, adding up to 180. So all I did was just take the information that they gave me, and I filled in the rest of the angles based upon the linear pair rule. Once I did that, well, then it becomes pretty apparent. Let me just put a pencil here so we can see here. We can see that line W and line Y have all their angles correspond, or to simply put it, all of their angles match. So then I know that line W is parallel to line Y with V as a transversal. If we look at line X and Z, and we put a pencil here blocking out this line, we can also see that line X and Z, how their angles are corresponding. So we can see here that X and Z are parallel. So basically X and Z are parallel, and W and Y are parallel because of their corresponding angles, and that would give us answer choice A. So yeah, so we can see here then that W is parallel to Y and that X is parallel to Z. Okay, again, just taking tip number 7, which says to mark up your test, and you can see that in the last 2 questions, all I did was mark this up, and it was the answer becomes easier to see. Let's move on to question number 5. Question number 5 says, a pharmaceutical company is designing a pill capsule for a new medication. The pill is shaped like a right cylinder. So if you look at your reference sheet, here is a right cylinder, right? So we can see that this part right here is shaped like a right cylinder with hemispheres on either end as shown below. So I have these hemispheres, right, which are basically half spheres. This is half a sphere, and this is half a sphere as well. And from that, I can see that the radius of my cylinder is, they told me that this is 6, right? Which means then that the diameter is 6. So I can see that the radius is going to be what? It's going to be 3. So the radius of the right cylinder is 3, as well as the radius of the hemisphere is also going to be 3. If you remember in class, we talked about the surface area of a right cylinder. And if you remember, we said, if you look here, by the way, the area of a circle is what? Is pi r squared, right? So the space inside of a circle is pi r squared. And if I have a cylinder, right, well, I know that this top lid here, right, is going to be pi r squared, right? But a cylinder also has a lid on the bottom as well, and that's also going to be what? Another pi r squared. So if you remember, one apple pie plus another apple pie is going to give me 2 apple pies. So basically this part of the formula right here, guys, really corresponds to the 2 lids of a right cylinder. So if you look here on my formula, here's the formula of the surface area of a right cylinder, right? But this part of the formula corresponds to the what? To the 2 lids. However, the outside of the, what you would think is the top part of the right cylinder is not exposed to the outside. So basically, I don't need that part of the formula. This part of the formula corresponds to the lateral portion here. of my right cylinder. Remember, we also discussed that in class. So basically, I know that if I use the surface area formula, I don't need this part of the formula. All I need is this part of the formula. And when I solve that out, 2 times pi times a radius of 3 times a height, which they tell me, by the way, is 14, I get 263.76. So I know that the area, the surface area of this part of the capsule is going to be 263.76. And basically now all I have to do is calculate the surface area of these two hemispheres. Well, if I remove this capsule here in the center, right, and I bring my two hemispheres together, what do I end up with? Well, you end up with a whole sphere. This is half a sphere and half a sphere. So basically, the surface area of a sphere, if you look at your reference sheet here, right, says that the surface area, the surface area, this is the volume, we don't want that. Surface area of a sphere is 4 pi r squared. It's 4 pi r squared. So if you look here, I took the surface area of a sphere, which is 4 pi r squared. So it's 4 times pi times my radius, which is 3 squared, which is 113.09. And I can use the whole surface area of a sphere because I have two halves that give me one whole, and that comes out to be 113.4. So the lateral portion of my capsule here has a surface area of 263.76. The sphere has a surface area of 113.04, and when I add those two together, I get 376.80. So the entire surface area of this whole capsule is 376.80. However, when you look at your choices, first of all, you don't see 376.80, and in addition to that, you should also notice that all of your answers are in terms of pi, right? So what do I have to do with this surface area here that I received? Well, I got to put it in terms of pi, right? How do we do that? How do we put an answer in terms of pi? Well, I take it and I divide it by pi. I divide it by 3.14, and when I do that, I get 120 pi, which right here, we can see that the answer is going to be, let me just double check that real quick, 376.80 divided by 3.14 divided by pi gives me 120 pi. Gives me 120 pi, which is choice B. The answer is choice B. Let's move on to question number 6. Question number 6 says, which segment is an angle bisector? Which segment is an angle bisector? Is it AE, is it BG, CD, or FG? Question number 6 was pretty simple. If you notice here, we have this segment here, and we have these two angles which are congruent, which means that angle A is being bisected into two equal parts. So obviously, segment AE is the angle bisector. We don't see any of the other segments bisecting any angles. So the question to answer to question number 6 is going to be letter A. Segment AE is an angle bisector. It's bisecting angle BAC or angle CAB. Let's move on to question number 7. Question number 7. Okay, we have a regular pentagon here, which means all the sides and angles are congruent. And we have a regular hexagon here, which means all the sides and angles are also congruent as shown below. They want to know what is the measure of angle ABG. And if you notice, angle ABG is this angle right here on the outside. And we don't have any number for any of these, right? Well, if you remember and you look at your reference sheet, you can look here and remember at the bottom of your reference sheet, right guys, here's our reference sheet, and if you look at the bottom here of your reference sheet, it tells you in a polygon, the sum of the measures of the interior angles is equal to this formula right here, 180 times n minus 2. So you can use this formula right here, 180 times n minus 2, to know how many degrees there are inside any regular polygon, right? 180 times n minus 2. So when I look at question number 7, okay, well obviously I know that this is a pentagon, and n represents the number of sides. So if I say 180 times n minus 2, or 180 times 5 minus 2, which is 180 times 3, I get 540 degrees. That means that this pentagon has 540 degrees. If I take those 540 degrees and divide it by the 5 angles, each angle is going to be 108 degrees. I can also do the same thing for the hexagon here, 180 times n minus 2, or 180 times 6 minus 2, which tells me that a hexagon has 720 degrees. And if I take those 720 degrees and divide them by 6, that means that each angle here is 120 degrees. So I went from a situation where they didn't give me any numbers, and now I have a lot of numbers, right? Finally, the question is asking me, well, what's the value of angle ABG? Well, notice here I have this angle here, which is 108, and this angle here, which is 120. Now, they're not a linear pair, so they're not going to equal to 180 degrees. But if you notice here that if I add this angle here and this angle here, which are adjacent to each other, and I continue going, I create a circle. And in a circle, you know that you have 360 degrees. So this is 108 and this is 120. And if I add all of these three angles together, they should add up to 360. So if I take 360 minus 108 minus 120, I have left 132 degrees to complete the circle. And that is the answer for question number 7, 130.